Hello everyone, you are watching the Graphing Quadratic Functions in Context video. This is Mrs. Ruscio, and today we are going to do a lot of review, which is great. We are going to be using our technology to help us graph parabolas in context, and we might use a table or trace feature also to help us. So let's dive in. Example number 1. There is an object and it's traveling through the air and it's modeled by a quadratic function that's opening downward. Well, we can see that in the equation. They give us the equation and they tell us that the x value is coded as a t. So let's take a minute to graph this. Remember, when we type this in our calculator, we need to use x's instead of t's. Okay, which is what I have here. It looks like two straight lines, but we all know that this is not really what this should look like. It should look like an upside down U. So if we look at our graph, I have it graphed already, but take a minute, don't write things down yet, but we're going to use our graph to help us to change the scale. So 160 and 6. Okay, so let's change this 6.67. Oh, it's not letting me. Oh, yes, it is. Okay, so we're going to change that to 160. And I think 10 is okay. We could change it to 6 if we really want to, but aha, look at that beautiful parabola. Control T, let's get some points in this table. All right, here we go. 0, 80, 1, 128, 2, 144, 3, 128. Ooh la la. I found my vertex. There it is. And you have to say ooh la la and sing it in case you were wondering. And then if we go down in the table, 5, 0. And okay, we have a 6 in the table, which we can write the negative 112, but that means that the object is like going into the ground. So I don't think that that really makes sense. Okay, take a minute. You might want to pause the video at this point to graph it. This is what it should look like when you're done. So pause the video right now, use my graph to help you. And now we're going to answer some questions. So hopefully you pause the video to get that graph nice and beautiful. Make sure that you have all of those points plotted. What is the initial height, the starting height? If you said 80 feet, you're a rock star. Nice job, rock star. What is the maximum height? So how high does this go? Well, that's in a few different places in our problem. It's our vertex, our turning point, 144 feet. At what, and this is where people always make mistakes, at what time? Time is not in feet. Time is in seconds. It hits the ground over here at 5 seconds. And then over what interval is the height increasing? My graph is going up from here to here. We're using our x values only from 0 to 2. You could write an interval notation. You could write inequality notation. I don't care. You could even write it just like how I did here. But we just need to use the domain, the x values only for this type of question. That's usually where people make mistakes. Okay, example number 2. All right, we have a garden. Paul wants to have a garden, actually, and he gives us an equation. We're talking about the area of the garden is being modeled by f of w, and w is the width of the garden in feet. Pause your video and graph this. Does your graph look like mine? Because mine definitely does not look like a U, but it should because we have that x squared. But let's see why. Oh, it's because of our scale. Check this out. Our graph is going all the way up. I think this is to 200 and all the way out to 20. So let's change our scale. 200, 20. Haha, that looks a lot better. Now let's hit Control T. I am going to use my X scale to kind of help me, where I'm only going to record all of the even values, except, and I say this for my special point here, why am I putting this around that point? Well, it's special because it's the vertex. I'm going to get all of these points from my calculator, and I already did it just because I recorded this video once and it was really long, so I was trying to cut back on some time for all of you friends. You're welcome. But I did have to make sure that I put that vertex in there, okay? Because look at it, it says explain the meaning of the vertex. Well, let's take a minute to not only get the table down, but the graph down as well. You can take a moment right now, pause the video if you need to. Notice how I labeled. Notice how I have a lot of points in there. I connected them. You should do the same. Okay, part A. Hopefully you paused the video and completed the table and the graph. A says explain the meaning of the vertex. Well, first of all, let's identify this vertex. 9, 162, right? We boxed that right in. We saw that turning point happening right in our table of values as well, because I saw those 160s. Look at this rainbow action. You know the drill. Okay, but what does this mean? Well, F of W is area and W is width. So what is happening here? Well, the area is 162 and the width is 9. So when the garden, I have it typed out over here so it's easier to see because my handwriting is terrible sometimes when I'm writing fast. When the garden is 9 feet wide, notice how I used units, the maximum area, that's this, the 162, is 162 feet squared. Okay. Now, part B is very similar to A. What is F of 5? Well, you might look in our table. We didn't record it, so we got to go over here in our table in the graph, so you should be using your calculator at this point to get 130. So remember again, 5 is the width and 130 is the area. So what does this mean in the context of the question? Well, it just means when the width of the garden is 5 feet, the area is 130 feet squared.